Assalamu alaikum, dear students. Welcome to the 14th program in operating system lecture series, and today we'll expand on our discussion on the networks architecture and networks topology, and we'll cover network communications. Precisely today we'll discuss the network communication issues, networks robustness requirements, and network design strategies. You will recall that networks are composed of number of computing components or network elements or network components at one site, at different sites in the same city or in the same campus, in different cities, or even different countries of the world. A significant issue arises that how these machines, be they at the same site, at different sites in the same campus, in different cities, or in different countries, how to strategize, how to develop a mechanism so that these machines communicate with each other effectively and accurately. And our today's discussion will essentially discuss that. The prime communication issues in the networking arena are naming and name resolution, routing strategies, connection strategies, and contention strategies. Naming and name resolution, when we say we have number of machines at one site, at different sites in different cities or even in different countries, these machines need to recognize each other. Let's say we have a machine in Islamabad, we have a machine in Lahore. We have to provide these machines name so that the machine in Islamabad recognizes whether that machine is talking to a machine in Lahore or talking to a machine in Karachi. As such, naming conventions is an integral element in any network, and names are essential to be allotted or to be given to the machines so that machines on the network recognize each other. If they want to get a data or if they want to send data to each other, naming is essential. Second important element in the communication issues is the routing strategies. Let's say we want to send a message to Karachi, and we are over a network, and we have a machine in Lahore, machine in Faisalabad, machine in Multan, in Hyderabad, and so on. And we have number of alternative routes available to communicate with a machine in Karachi. Routing strategy will determine that how we route our messages from point A or from station A to station B. It is extremely important in the networking field. The next important issue in the networking area is the connection strategies. Connection strategies essentially determine that how do two processes send and the sequence of the messages. Let's say we want to communicate machine A with machine B, and connection strategies will determine that how do we connect machine A with machine B. And last but not the least, an important issue in the communication between the stations is the contention. We have repeatedly discussed that there are number of machines on the network. These machines may be from a few machines to a few hundred machines to even a few thousand machines. And it is not uncertain that a number of machines try to access a machine. Number of machines try to access one specific machine. As such, there will be a competition between a number of machines trying to reach certain specific machine. And in the communication area, we need to understand and try to have strategy to resolve if the contention occurs. And we'll discuss that in a little more details in our today's discussion. Regarding naming and name resolution. Name the systems in the network. As I mentioned earlier, names are extremely important, and we need to assign a name to every machine in the network, so that the other machines in the network, if they want to communicate with that machine, they are able to recognize that they are communicating with what particular machine. And then in the naming, address the messages with the process ID. If a machine A wants to send a message to machine B, then that message need to have a process ID assigned by the system, so that when the communication between the machines occur, then that particular message which is sent from machine A to machine B or from B to A, it is recognized that that particular message relates to which particular process that is happening between the systems. Now, identifying the processes on remote systems are with the host name and its identifier pair. Whenever the machines communicate, these machines send and receive a host name and identifier pair, so that the machines communicating with each other, they recognize from where the message is coming and what information has been requested, so that that information may be provided to the requesting station or requesting site. Another important element in the naming and name resolution is the domain name service, which specifies the naming structure of the hosts as well as name to address the resolution. For example, if we say we have address, let's say a machine in Lahore, which is owned by Allama Iqbal Open University, we can call LHR.AIOU, means the machine at Lahore of Allama Iqbal Open University. Similarly, we can have KHI.AIOU. Naming domain name, assigning the domain name is also essential in naming a resolution amongst the networks. The next important communication related issue in the networks is the routing strategies, and primarily there are three routing strategies. Number one is fixed routing, number two is using virtual circuits, and number three is dynamic routing. In fixed routing, a path from machine A to machine B is specified in advance, and path changes only if a hardware failure disables it. Since the shortest path is usually chosen, communication costs are minimized. And but there is a problem in the fixed routing, that fixed routing cannot adapt to load changes, although it ensures that messages are delivered in the order in which they were sent. Since we have already determined in advance what is the route, then that route cannot adjust itself if there is a change in the load along that route. The messages in whatever sequence the messages will be sent, they will be passed on and received in the same sequence. Virtual circuits, primarily a path from A to B is fixed for the duration of one session only. And if we have multiple sessions, the different session involving messages from machine A to machine B may have different paths. And this provides us a partial remedy to adopting the load changes. If along that particular path from machine A to machine B there is a load change, it provides us a partial adjustment to that, because as long as we have a session, as long as that session continues, the path will stay the same. Once the session changes, we have next session, the path may be different. It ensures, the virtual circuit strategy ensures that messages will be delivered in the order in which they were sent from the sending stations. And normally in the virtual circuits, they share the medium of the telecom companies from site A to site B. The next routing strategy is dynamic routing, in which the path is not determined in advance. As the messages come, the path of the message from machine A to machine B is determined as the messages come. The path used to send the message from site A to site B is chosen only when the message is sent. And usually a site sends a message to another site on the link least used at that particular time. The beauty of the dynamic routing is that the system determines which link is least used, so that the message from machine A to machine B is transferred in the most efficient manner. And it also adapts to the load changes by avoiding the routes which are most heavily used. The messages in the dynamic routing may arrive out of order. This problem can be remedied by appending the sequence number to each message. We saw that in the dynamic routing, the route is determined as the messages are sent. It adapts to load changes by sending messages at the least used routes, and if one route gets burdened with the number of messages, then they adjust itself. That message, the subsequent messages can go at a different route, and it also creates some problem. Although dynamic routing provides lots of benefits, it provides a problem that the messages do not go in the same sequence, but they will have to be assigned some sequence number so that they are reassembled when they reach their destination. Then they are reassembled in the same order they were sent, and then that message makes some sense, and it comes in the format it was originally sent from the sending station. Dear students, another important issue in the communication amongst the network is the connection. When we want to connect machine A with machine B, we have a number of strategies available to connect the two machines, and we can have a circuit switching strategy, we can have a message switching strategy, or we can adopt a packet switching strategy. The circuit switching requires the setup time, but it incurs less overhead for shipping each message, but we have a drawback that it may waste network bandwidth. Message and packet switching requires less setup time but incur more overhead per message. What does that mean? That means that in circuit switching, we develop a connection between two machines, machine A and machine B. When the machines are connected, that connection stays valid as long as these two machines, as long as that circuit stays on, and as long as these two machines continue to communicate. Regardless the amount of information sent from A to B or from B to A, it may be less, it may be more, the bandwidth that established circuit has, it will continue there. As such, in the circuit switching, we may have some bandwidth loss, or bandwidth may not be used as effectively as it is possible in other strategies. However, as long as the connection stays, we can continue communicating between the machines. As I discussed in circuit switching, permanent physical link is established for the duration of the communication. Whereas in the message switching, temporary link is established for the duration of the one message transfer. If we want to transfer and we are using the message switching strategy, once we start transferring a message from machine A to machine B, our connection will be valid only for the duration of that particular message. For the next message, we may have a different route. Yet for another message, we may have another route, right? Whereas in the circuit switching, the permanent physical link is established as long as the communication continues. In the packet switching, messages of variable length are divided into fixed length packets which are sent to the destination. Each packet may take a different path through the network, and the packets must be reassembled into the message as they arrive. Now, looking at the connection strategies in the circuit switching, a circuit is established and stays valid as long as the communication continues. In the message switching, the connection between machine A and machine B is only valid for the duration of that particular message. And similarly, in the packet switching, the connection between machine A and machine B is only valid for that particular packet. The route for each packet may be different. As long as the communication continues, we will have a different routes for, we may have a different route for each packet. And in fact, in message switching and in packet switching, we achieve the maximum utilization and efficient utilization of the bandwidth available between the two stations. Next important issue in the communication amongst the network is the contention. As you know, we have a number of machines on the network, and at any given time, number of machines may try to reach any particular machine. As such, they may cause contention. We need to have strategies to avoid contention or overcome contention, and fortunately, we have number of strategies available. As I discussed, the several sites may want to transmit information over a link simultaneously, and there are a number of techniques to avoid repeated collisions include CSMACD, that is carrier sense multiple access collision detection mechanism, token passing mechanism, and message slots. In CSMACD, a site determines whether another message is currently being transmitted over that link. When two or more sites begin transmitting at exactly the same time, they will register a collision detection and will stop transmitting. When the system is very busy, many collisions may occur, and thus performance may be degraded. And CSMACD is very successfully used in the Ethernet networks. In the token passing, a unique message type known as token continuously circulates in the system, and that system is usually in the ring structure. A site that wants to transmit information must wait until the token arrives at that site. And when that site completes its round of message passing, the token is retransmitted on the network so that the next machine may be able to, the machine which receives token may be able to transmit information to that particular site. The third contention avoidance strategy is the message slots. And in the message slots, a number of fixed length message slots continuously circulate in the system. Again, usually a ring structure. Since a slot can contain only fixed size messages, a single logical message may have to be broken down into a number of smaller packets, each of which is sent in a separate slot. This scheme has been adopted in the experimental Cambridge digital communication ring networks. Dear students, the next important issue in the network communications is the robustness of the network, and that means the failure detection and reconfiguration. For example, we have number of sites or number of stations on the network. If a link fails or if a site fails, then we need to have a mechanism to detect that failure and inform the machines on the network that a failure has occurred. And once a failure has occurred and we need to reconfigure a machine, the network should be able to reconfigure the failed site or the failed link. I will discuss the failure detection in a little more details. Let's say site A and site B have established a link, and at fixed intervals each site airs a message that I am up. If message not received, either of the system is not up or the message was lost. In that case, either of the system A or site A and site B, they can broadcast a message that are you up, means it can ask if the message from the other side is not coming, the other side, corresponding side, can ask are you up. If the site A, let's say, does not ultimately receive the reply from site B, it concludes some type of failure has occurred, and there may be a number of different types of failure. For example, site B is down, the direct link between A and B is down, the alternate link from A to B is down, the message has been lost, or a combination of that can occur. However, a site A cannot determine exactly why the failure has occurred. Next important issue in the robustness of the network is its reconfiguration. And when site A determines a failure has occurred, it must reconfigure the system. For example, if the link from A to B has failed, this must be broadcasted to every site in the system. And if the site has failed, every other site must also be informed or notified, indicating that services offered by the failed site are no longer available. And similarly, when the link or the site becomes available again, this information must again be broadcasted to all other sites. The reconfiguration issue amongst the sites is, number one, if the link fails or a site fails, all other sites on the network must be informed that the link has failed or certain site has failed. And at the same time, when the site becomes available or the link becomes available, other machines on the network needs to be informed that now link is available as well as or the site is available now, or site has reconfigured, and it can the other stations on the network can communicate with that particular site or over that particular link. The next critical issue in the network communication is certain design issues, and important design issues in the network communication are the transparency, the fault tolerance, scalability, and the clusters. The transparency means that the distributed systems should appear as a conventional centralized system to the user. The fault tolerance capability of a network provides that the distributed systems should continue to function in the face of failure. If a link fails or if a site fails, the system continues to function as usual. The scalability is another important consideration in the network design, and that means that as the demand increases, the system should easily accept the addition of new resources to accommodate the increased demand. And the last important design issue in the networks is the clusters, which means that a collection of semi-autonomous machines that acts as a single system. Dear students, this completes our today's discussion on primarily on network communications, and today we covered the network communication issues, network robustness, in which we discussed the failure detection and reconfiguration, and then we looked at the important considerations in network design. This completes our today's discussion. Until next time, Allah Hafiz.